All right, we return to lesson 9.5, which is our final way to solve a quadratic. And it's based a lot on patterns. So I've actually left this bell work piece filled in so we can analyze those patterns first. Then we can go through the steps of actually completing the square. So first things first, whenever you factor, and I have these all factored and ready to go, if something is considered what we like to call a perfect square trinomial, it means that it factors into two sets of parentheses that are the exact same. So here on A, you can see that x squared minus 6x plus 9 has factored into x minus 3 times x minus 3. The reason why this is a goal for this method of solving is because its ability to be condensed down so that you can write it as the quantity of x minus 3 squared. So that's the first pattern I would like you to see. So that's kind of the definition that we have for a perfect square trinomial. How is this going to play into the method that we're using? Well, there's two patterns. The first of those patterns is the relationship between the b term and the value that's inside. So if you took a quick glance at them and wanted to take a guess before I tell you, you may notice that the term inside the parentheses is always half the original b. And we've written that down here as well. So when you try to use this method to complete the square, the goal is that the value inside is half of the original b. The other piece of this, however, is to create this value right here. So if we look at A, if we didn't know what that number was, and we were told to write a trinomial, so 3 terms, that was a perfect square trinomial, how could we use the other 2 terms to relate? So you'll notice the relationship between this value and that final value. Let me go ahead and mark them all real quick. So 1 to 1. And in this case, we have 9 to 81. So you'll notice in all 4 of those examples, so a 3 to a 9, 4 to a 16, 1 to a 1, 9 to an 81, all of those C terms are that this value inside, it's that number squared. So that's the other relationship that we're looking for. We know that the C term is the result of taking half of the middle term and squaring it. And these 2 pieces become very important and are, in essence, the way in which we will set this problem up so that we can eventually solve it by square roots. So that even though this method is called completing the square, the last steps to solving it are using one of the other methods we have already covered. All right, so here in this box, we're going to write in that this process, oops, let me go a little thinner. Will create a perfect square trinomial. So when you look at the homework for this week, you'll notice it's a part 1 and a part 2. Part 1, the goal is all about just practicing using this formula right here. You'll notice that that worksheet is termed finding the value of C. So if you wanted to pause this video after we complete this example number 1, and use that to just do the worksheet, you could. This is all you should need to complete the worksheet. So our goal is to find the value of c so that we can create a perfect square trinomial. So you'll see that we have our first two terms. Our goal is to find c. So yes, another formula. C is found by taking the b term divided by 2 and squaring it. So b in this particular case is -4. -4 divided by 2 is a -2, and a -2 squared should be 4. Now, because of the fact that we're squaring, this last number should always be positive because a squared will take care of it no matter if it's negative or positive. If you'd like to pause the video here before we do example B just to see if you understand, feel free. So same idea. If I have my first two terms in my trinomial and I want to know what should this be to create a perfect square trinomial, I take b divided by 2 and I square. B in this particular case is a 5. Oops. You could do this in decimal form if you like, or you could keep it. So if you wanted to keep it here, 5 squared is just 25. 2 squared is 4. Just make sure you square both the top and the bottom. That's our exponents properties coming back in. Or if you would like, you can go ahead and write it in its approximate form, which is 6.25. Or I should say decimal form. That's the exact answer too. All right, that is the process of creating a perfect square trinomial. So that's kind of the first bit. When you choose this method, step number 1, well, maybe not step number 1, but one of our major steps toward the beginning is to find this value. All right, so let's kind of look at our steps. Oops. So before we complete the squares, technically that is step 2, our goal is to make sure it's set up for the purposes of completing the square should we choose this. Now, it is possible that the problem will already have a c, but that c doesn't create the perfect square trinomial we want. So what we do is we take the c that's there and we move it. So in this particular case, if you wanted to test this out, this number is not going to make these first two terms into a perfect square trinomial. So your goal is to move it over to the other side. In this particular case, it is already there. When we get to example 3, you'll get a chance to see what that looks like when we actually have to move it. So that's step 1. Step 2. Here's when we complete the square. Which means using our formula, b divided by 2 squared. So over here to the side, I'm just going to kind of do this in this middle space. To find the value of c that we want to complete the square, we're going to take the b term, which is a -16. We're going to divide it by 2 and square it, and we should get a 64. So how do we insert this into our actual problem? So we have on the left-hand side x squared minus 16x. We are going to add in this value that we know creates a perfect square trinomial, and it's 64. So there we've got it. That's what our goal is. However, in an equation, which this is, we can't add something to one side and not the other. So to keep the two sides balanced, this value that we have found, we add it to both sides so that our equation is balanced. We chose 64 because that's going to create what we want on this side. But what we do on one side, we must also do to the other. So the process of completing the square is not only finding that value, but then adding it to both sides. All right, step 3. We're going to do something different on each side. So on our left side, I say left side. It's possible your problem would be set up where this be on the right, but typically it's on the left. On the left side, we're going to factor, and we can use our pattern if we'd like. And on the right side, all you need to do is add. So let's start with factoring first. It's a green light problem, so we want factors of 64 that will add up to a negative 16. You could write all these out. However, hopefully you get to the point where you notice that when you're doing this, your goal is to find two numbers that are the same, because the whole purpose of completing the square is to create something where this is the case. Now, sign-wise, since it's a positive 64, we need both of these to be negative to get our negative 16, which means this technically factors into x minus 8 times x minus 8. However, for the purposes of solving and completing the square as a method, the goal is to rewrite this as x minus 8 quantity squared. Whenever we multiply two things that are the same, we can condense them down with an exponent of 2. So that is the process on the left-hand side. On the right-hand side, you just need to go ahead and add negative 15 and 64 together, and we should get 49. At that point, we technically are done completing the square. The whole goal, and this is kind of what it looks like on con. On con, your goal is to figure out which number should go here and what value should be on the other side. This is where completing the square in essence stops. So, how do we use this method to then solve? We call upon a method from earlier in the chapter, and our final step is to solve by taking square roots. So we have a quantity squared. To get rid of the squared portion, we just square each side, which would leave us with the x minus 8. We square root 49. Remember, the value under is positive. We put plus or minus. Square root of 49 is 7. To finally get x completely by itself, we add 8 to the other side. Let me go ahead and color the code that differently. Our x here is going to be 8 plus 7 and 8 minus 7, which should give us our two answers of 15 and 1. And that is solving a quadratic by completing the square. Now this one has a lot of steps and another formula to memorize. The beauty of this one, just like the quadratic formula, is it works no matter what. Now there are some things that can complicate this that make using this harder than the quadratic formula, which we'll talk about here in a second. But the beauty of it is the fact that it can work no matter what. But if normally people have the choice between this and the quadratic formula, they tend to go the quadratic formula route. But that is completely up to you. When you become more familiar with it, it becomes a nice option. All right, so if we move these steps down to this last one, I already have them written in here, we're actually going to add one more piece to part 1. And that is this. To set up this problem for completing the square or any quadratic, not only do you need to move c, but you need your leading coefficient to equal 1. And this is where this method can get kind of messy. The way to get it equal to 1, so let's look at that part first, is to divide everything by whatever's there. So if you say, I am going to complete or solve this by completing the square, so you've chosen that method, and you go to set it up for this method, you would notice, hey, this is a 2, not a 1. So your way to make it a 1 is just to divide everything by that number. Now on some problems that's going to work out beautifully, on others it's going to create fractions. And so sometimes this can get kind of messy, and you'll realize that the quadratic formula may have been an easier route when it comes to methods that work no matter what. So that would have been part of step 1. The second part of step 1 would be to move this value over. So 4 does not make this problem a perfect square trinomial. And should you choose this method, that is your number 1 goal, to get it set up for this. And there would be step 1. All right, which takes us to step 2, which is to complete the square and then add that to both sides. So we're going to take b divided by 2 and square it. So in this particular case, it's the b that's there after you divide. So that's a 10. Oopsie. So 10 divided by 2 squared should give us 25. So we go ahead and add that to both sides. Now you don't have to put the little box. I like to put the little boxes as a reminder that something is happening on both sides, and that's where that value is that we've added in. All right, which takes us to step 3. We're going to factor the left-hand side. Now on this particular one, I'd like to point out the pattern from the very beginning. So up in that bell work, we found out that the value that this factor is into is always half of the b term. So yes, you can factor it, but if you can memorize the pattern, it makes this process go much faster. And you'll recognize that this number is always just half of this value. So if I divide it by 2, I should get that number. And again, we're going to go ahead and write it as a quantity squared. Now, if you're ever using this method and you forget that pattern, it's not the end of the world. You can just go ahead and factor it by hand. All right, our other side, we just add these two together. So 4 plus 25 should give you a 29. All right, last but not least, solve by taking square roots. So I know if I take the square root of this side, it eliminates the squared, giving me x plus 5. On the right-hand side, I take the square root. The square root of 29 is not exact, so you have two choices. You could leave it as the square root of 29. Let me go ahead and do that choice first, and then I can show you what this process would look like if you go ahead and calculate that. Square root of 29 doesn't simplify, so my final step here would be to subtract 5. If I leave this in exact form, my answer would just be negative 5 plus or minus the square root of 29. That is one way I could leave this answer. If you would prefer to go ahead and take this to more of an approximate, at this stage of the game, you could have written it as its approximate answer. So if we do to the nearest hundredth, we would get 5.39 for the square root of 29. You would still subtract 5 over, and then you would calculate both of the options here. So option number 1 would be a negative 5 plus 5.39. Which gives you 0.39. And then we'd go negative 5 minus 5.39. Which gives us a negative 10.39. 39. And there would be your two solutions. So that would be your approximate solutions. The first answer would be your exact. And that is the process of completing